Hello and welcome to Module 1, the History and Value of Systems Engineering, where here we will talk about transgressions of systems engineering. This is a lot of do's and don'ts that come with the field of systems engineering. Today we will talk about what we refer to as the 12 deadly systems engineering transgressions. The first one is an over-reliance upon a specific analytical method or tool, or a specific technology that is advocated by a specific or particular group. An example of this would be somebody wanting to use simulation modeling for everything. Somebody with very experienced modeler may want to do this, but they may not change the actual model or then go and validate assumptions. The old saying goes, if the only tool you have is a hammer, everything starts to look like a nail. The second transgression is consideration of a perceived problem and issues only at the level of the symptoms, and the development and deployment of solutions that only address the symptoms. This exhibits a lack of root cause analysis and data decision driven making. The risk here is that you, for example, may not validate requirements and wind up spending a lot of time to hone in on something that does not actually fix the problem. In the end, this will end up consuming a lot more time and resources and move you no closer to resolving the original issues that prompted the effort. This is a frequent occurrence in manufacturing, designing an improvement without actually identifying the root cause first. We will talk more about this when we get to DMAIC and some of the lean tools later on in this course. The third transgression is the failure to develop and apply appropriate methodologies for an issue that will allow identification of major pertinent issue formulation events, a fully robust analysis of the variety of impacts on stakeholders and the associated interactions among steps of the problem solution procedure, and interpretation of these impacts in terms of institutional value controls. This is another way of saying suboptimal solutions, essentially band-aiding a problem with a solution that may work, but not as effectively as it could and only creates issues down the road. The fourth transgression is failure to involve the client to the extent necessary in the development of problem resolution alternatives and systemic aids the problem to resolution. The key words in here are to the extent necessary. Very frequently people will go and engage this client to keep them involved, but very rarely do they keep them involved to the truly extent necessary. In this case, the client could also be the customer or stakeholder, and they're critical for many elements, such as understanding the root cause, requirements, current performance, etc. It's very important to establish that feedback loop. The fifth transgression is failure to consider the effects of cognitive biases that result from poor information. A hardware engineer, for example, might be predisposed to think primarily of hardware solutions. On the flip side, a software engineer might be similarly biased towards software-based solutions. The best option may be one or the other, or a combination of both, or perhaps something different altogether. The sixth transgression is failure to identify a sufficiently robust set of options or alternate course of actions. People often want to jump right away to fix one potential solution that could work, oftentimes trying to band-aid the problem. While it's natural to want to go to fix a problem with a solution staring right in front of you, oftentimes this will result in a suboptimal result and ultimately a longer amount of time to ultimately resolve the issue. The seventh transgression is failure to make and properly utilize reactive, interactive, and proactive measurements to guide the systems engineering effort. Surprises do happen, but reactive action should wind up being the exception rather than the norm. The unfortunate reality is this is often not the case. When surprises happen, a reactive effort, even then, should be done while the issue is occurring, but best option altogether would be a proactive approach to begin and address the issue before it became a problem. The eighth transgression is failure to identify risks associated with the costs and benefits or effectiveness of the solution to be acquired, produced, or otherwise fielded. It's important to identify this risk during system development. Risk includes cost, resource overruns, safety, or even just the risk of the system being effective entirely. The ninth transgression is that there is a failure to properly relate the system that is designed and implemented with cognitive style and behavioral constraints that impact the users of the system, and an associate failure of not properly designing the system for effective user interaction. Fail to consider how operations or customers will use the product is a common issue. The $1 billion Hamachi helicopter program is a great example of this and a large-scale project on the U.S. government's behalf. Ultimately, the design failed to consider the 95th percentile of users and wound up with pilots unable to reach all of the necessary controls. The 10th transgression is that there's a failure to consider the implications of strategies adopted in one of the three life cycles on the other two life cycles. In this case here, planning and marketing, research, development, test, evaluation, and then acquisition and production. The 11th transgression is the failure to address quality and sustainability issues in a comprehensive manner throughout all phases of the life cycle, especially in terms of reliability, availability, and maintainability. Consider how the product will be sustained and serviced. Changing on a car, for example, is very simple enough and it can often be done without a mechanic. However, to change a fuel pump could require a mechanic to remove multiple engine components just to get to it. Nothing's more frustrating than an end user being told by a mechanic that it's 15 minutes worth of labor, but it will cost them 4 hours worth of labor cost in order to just get to the product and make the change. Another example would be the space shuttle, which would have very significant limitations in the ability to service, both because of the unavailability of people to do the work as well as the difficulty of getting replacement components. And the 12th transgression is failure to properly integrate a new system together with heritage or legacy systems that already exist and that the new system should support. This is frequently an issue within software. Upgrading one software component could cause issues with other components. An example of this is with the health insurance industry, which has undergone major changes since the passing of the Affordable Care Act. Many providers and insurance companies put in all new infrastructure systems to be able to handle the new Affordable Care Act government requirements. As a result, they oftentimes overlooked their existing legacy systems, figuring that the legacy systems would become out of date in a matter of 3 years. The reality is, with the delays in the implementation of law and changes in government administration and priorities, the legacy systems have stayed on much longer than the others and was not properly planned for and has caused issues within their new systems.